All right, finishing up 12.1, we talk about paired t-tests. And really, if you have like before and after scores, just like we saw in that sweetness one last night, where it was the sweetness before and the sweetness after, you're actually performing what's called a paired t-test because you're pairing up the before and after scores and you're finding a difference, and then you're doing the t-test on the difference. So that happens with before and after. It happens with matched pairs, which if you remember I talked about, like doing left and right foot or left and right hand or left arm and right arm or left eye and right eye or twins. You'll do matched pairs design often, okay? And if you have matched pairs, then there's an individual for each individual, the individual taste tester or the individual sample of soda or the individual whatever, you the things are paired up. So find the difference per each pair and then do a t-test on the differences, okay? And I'll show you an example in a second, okay? The other thing that's mentioned here in this little section is how t-tests are robust, except when there is strong skewness or outliers. So if they tell you to perform a t-test or perform a hypothesis test and you think that there might be moderate skewness or outliers, just say proceed with caution. But if it asks you in a multiple choice question, should we perform a t-test? These are the reasons why you would say no, okay? But let's take a look at a paired test. All right. So we hear that listening to Mozart improves students' performance on tests. Perhaps pleasant odors have a similar effect. So they give 20 subjects, do a paper and pencil maze while wearing a mask, and it was either unscented or had a floral scent. And the response variable is their average on 3 trials. Each subject worked the maze with both masks in a random order, and it's important that they tend to improve their times. You get better at mazes. So randomizing the order is why they, because any improvement of time would be maybe they did this one first, maybe they did this one second. So notice we think that maybe the scent will improve their time. So we would take the difference. This was subject 1, and so we're looking for a change between these 2 times, change between these 2 times, change between these 2 times. And so we have 21 subjects, and they each have times with unscented and scented, okay? And what we would do is take the difference between those and do a t-test for a difference. And really, no difference is 0, so that's always your null when you're doing a paired t. And then you're, depending on which way you've subtracted, okay, if we think that the scented is faster, we would actually expect a positive score. So like for this person, the scented was faster by 4.1 seconds on average, and this person 20 seconds on average. So my alternative would be the mu difference is greater than 0, okay? Because that's what we're looking for, is that the scented makes you faster. And then you would perform your hypothesis test just on this. So I would like to L1, L2, and then subtract L1 minus L2 in L3, and then I would do my t-test on L3, okay? But that's what we're looking for when we do a paired t-test, all right? But it's the same as it looks like a one sample t-test in the end because you subtract beforehand and you just have one column of differences, okay? And we'll get to 2 samples later. So good luck and farewell.